I'm covering 5-9 today, which is operations with complex numbers. So we're going to perform those, adding, subtracting, multiplying. So adding and subtracting complex number is similar to adding and subtracting variable expressions. You kind of treat the I like you would x in an expression, and then at the end you can simplify it by changing any I squareds into negative ones. But we will combine the real parts and the imaginary parts separately before we simplify, just like you combine the numbers and the variable expressions separately. And this may be a helpful hint. Complex numbers have additive inverses, so a plus bi, if you add negative a minus bi, you're going to get 0. All right, so example, add or subtract, write the result in a plus bi form. And again, you're going to want to combine like expressions. We have our two real parts, our two imaginary parts. So 4 minus 6, and then you've got positive 2 minus 7i, which your final answer, negative 2 minus 5i, which is in a plus bi form. Next example. Similar, but notice we have the subtraction here, so you want to distribute that, just like when we learned to do with variable expressions. So it ends up being 5 minus a negative 2 is 5 plus 2. So that's what's happened here. And then minus a negative 3i becomes plus 3i. And now we can combine our 5 and 2 and our negative 2i and positive 3i to get 7 plus I as our final answer. All right, 1 minus 3i plus negative 1 plus 3i, and you might know this is might notice it's an additive inverse. If we add 1 and negative 1 and negative 3i and positive 3i, we end up with 0. All right, one for you to try. All right, next we're going to work on multiplying. So we multiply complex numbers by using the distributive property, just like you do with variable expressions, treating the imaginary parts as like terms. Multiply, and here's the example, multiply, write the result in a plus bi form. So we're going to distribute this. So that gives us a negative 2i times 2, and then a negative 2i times a negative 4i. And so we can multiply the negative 2 and positive 2 to get negative 4, and then the I just stays as I. Here we're going to multiply the negative 2 and negative 4 to get positive 8. The I times I becomes I squared. But remember, I is the square root of negative 1, so I squared is the square root of negative 1 times the square root of negative 1. When you square something under a square root, it basically just removes the square root, and you end up, in this case, we're going to end up with negative 1. So we're replacing the I squared with negative 1, and then this becomes negative 8 minus 4i, and in a plus bi form, it's negative 8 minus 4i. Here we've got to FOIL. So remember, if this were 3 plus 6x times 4 minus x, we know how to FOIL it. Exactly the same thing here, and we'll simplify any of these I squared terms at the end. So we're going to get 3 times 4 is 12, and then 6i times 4, they didn't actually FOIL, but if you did FOIL, it would be 3 times 4 is 12, 3 times negative I is negative 3i, 6 times I is plus 24i, and then lastly, 6 times negative I becomes negative 6i squared. We can combine our two like terms, which are with the i's. Notice we're not going to combine it with an I squared, just the same as you would not combine a 6x with a 6x squared. So combine those two to get 21i, and then we're going to replace our I squared with negative 1. and that ends up giving us 12 plus 21i, and negative 1, 6 times negative 1 becomes positive 6, and then we can combine our two numbers to get our final answer. Okay, I think we have a couple more of these I'm going to show you. All right, multiply, again, FOIL it. So for, whoops, negative 18i, positive 18i, and then negative 81i squared. You can see how these are going to cancel out. Replace the I with negative 1, and you're going to end up with 4 plus 81, which gives you 85 as an answer. So you probably would not have expected that if you looked at this expression, but that's what you get. Okay, negative 5i times 6i, multiply the two numbers to get negative 30. I times I is I squared. Replace the I squared with negative 1, and we end up with 30 as our answers. So sometimes you start with a complex expression and get a real number as your answer. All right, so one for you to try. You try this one. All right, so powers of I to the first power is just 1, I squared is negative 1, I cubed becomes negative 1, so it's I squared times I, which is negative 1 times I, or negative I. I to the fourth is going to be negative 1 times negative 1, which is 1. And then if we go up from there, I to the fifth is I, which is the same as this. I to the sixth is negative 1, so you can see now we start repeating. So powers of I are going to either end up being I, negative 1, negative I, or 1, depending on the power. And we're going to use this repeating pattern to help us simplify expressions that have powers of I greater than 2. All right, so simplify 6i to the negative 14. So we can rewrite this as negative 6i squared to the 7th. Remember, we know that I squared equals negative 1. So then it becomes negative 6 times negative 1 to the 7th. Negative 1 to the 7th is going to be negative 1. If we write it out 7 times, it's going to end up equaling negative 1. And negative 6 times negative 1 is 6. So if we rewrite the higher power in terms of powers that we know already, then we can easily calculate this. Simplify I to the 63rd power. So it's I times I to the 62nd power. Does that help? Which is I squared. So you want to get it to an even power so you can rewrite it in terms of I squared. So it's I squared to the 31st power. So this is going to be negative 1 to the 31st. If this is an odd number, we're going to end up with being negative 1. If this were an even number, such as negative 1 to the 32nd, it's going to end up being a positive 1. So we have I to the negative 1. So negative I to the 31st is going to be negative 1. So I to the negative 1, or I times negative 1 is just negative I. All right, so you simplified this. All right, let's go to division last. Simplify 3 plus 10i divided by 5i. And even though we have written the square root of negative 1 as I, it doesn't matter. We still can't have square roots in the denominator, so that means we can't have I in the denominator, because it is a square root, even though we have a nice fancy name for it. So to simplify it, we're going to get rid of the square root by the same thing we did before, multiplying by, well, in this case we're multiplying by a negative 5i over negative 5i, and so we end up with a positive number in the denominator. But so we distribute this and we multiply this. This is going to be negative 15i minus 50i squared all over, and this becomes negative 25i squared. We replace our I squareds with negative 1, so negative 15i minus 50 times negative 1 over negative 25 times negative 1. Let's see, have we gotten there yet? And that's where we get to this. This is going to be negative 50i. Negative 50 minus times a negative 1 becomes plus 50. Negative 25 times negative 1 is plus 25. So we're here. And I'm trying to see, we can actually factor 5 out of all of this. So this is going to be 5 times a negative 3i plus 10 over 5 times 5. And they actually, now if you rewrite this in a plus bi form, becomes 10 plus, sorry, minus actually, 10 minus 3i over 5. They went ahead and simplified. 10 divided by 5 is 2, minus 3i over 5. So you should always try to simplify as far as you can. All right, here's one for you to try. And that concludes this lesson. The homework is, here's the homework. Bring your questions to class.